Welcome to Code to Enhance Learning Computer Science Unplugged video series. A video series to learn about exciting computer science concepts used to design computers and applications through fun activities without using computers. Get ready to think, be creative, and boost your 21st century skills to thrive in this innovative world. In this lesson, we will look at an interesting way to find the shortest path from one location to another. Imagine your friend has invited you to his birthday party. You know where he stays, but you don't know how to get there. So you ask for directions. They tell you to go straight, take a right at the crossroad, and take the first left from there. Another person might tell you a different path. The question that might come to your mind is, which one of them is the shortest path? To answer questions like these, Google has an app called Google Maps. Using this app, you can enter a destination and the app will show you the shortest path from your location to your destination. As you apply the technique of shortest path, you will be developing critical thinking ability and numerical aptitude. To solve the problem, we need a way to represent this information in a mathematical way. Suppose you have two different routes to take to reach your friend's house. Let's say from your home, you can either walk to your friend's place or go to the bus stop, board the bus goes around town and finally drops you at your friend's place. We can assume the locations to be points on paper. If there is a way to reach from one point to another, they are connected by a line. Say you have to go from your house to the bus stop. If there is only one path to reach the bus stop, you can connect your house to the bus stop. The distance between them is written as a number on the line or above the line. In that way, we can connect all the locations together. This diagram is called a graph. Once we have the graph, we are going to perform certain steps on this graph to get our answer.
As you have seen in the video, this is our graph. The first circle over here represents our home, the second circle represents the bus stop, and the third circle represents our friend's home. The distance between our home and the bus stop is 1 kilometer. The distance from the bus stop to our friend's home is 2 kilometers, and the distance from our home to our friend's home is 4 kilometers. Before we go ahead, I would like to give an intuition on how it works. It works on the fact that if the shortest distance to your location is the sum of the shortest distance from the starting to each of the locations you encounter to reach your destination. If you have 3 locations in between your starting and ending, you need to pick the shortest path to each of these locations to get the shortest path to your destination. Keeping this in mind, we are going to visit each of the locations and apply the same steps. To begin, we are going to create a table. The table has 3 columns and the number of rows in the table is the number of locations. In our case, it will be 3. The first column represents the location. The second column represents the shortest distance to that location. The third column tells us from which location we got the shortest distance. This will help us find the path finally. So that second column finds the shortest distance and the third column helps us to find the path that we will take. So let's draw the table. So I have got 3 columns and I have got 3 rows. I will label these locations as A, B and C so that it is easy for us to write in the table. Imagine writing our home 4 or 5 times. And I will assume I don't know the distances to any of them. So I will cross them. You can write unknown as well. And I do not know the values in my third column. I will cross them as well. Okay, Using the powers of video editing, I have created the tables that I need to complete the shortest path technique. We will start at A because A is our home. Now we ask ourselves, who are the neighbors of A? It is B and C. Their distances are 1 and 4 respectively. Because the values were unknown before, we are going to change it to 1 and 4. And because we have changed the values, we are going to put from where we have got these values. We have got it from A. So at this point, we can say that the shortest path to B is via A, and that is a distance of 1. And the shortest distance to C from A is 4, and it is via 4. What about A? A, it is 0 because we are at A and we don't have to travel anywhere, and it is via A itself. Okay. Next, we are going to move from A to its neighbor. Now A has 2 neighbors. Which neighbor are we going to choose? We choose B because B has the shortest distance, that is 1. Between B and C, B has the shortest distance, and we mark A as visited. We mark A as visited because we don't want to come back to A. We want to keep track of all the locations that we already visited. Now that we are at B, who are the neighbors of B? That is A and C. We can ignore A because we have already visited A. The distance of C from B is 2, and we see that the existing distance is 4. Is 2 less than 4? Yes. But are we going to put the distance as 2? No. We need to first check if the shortest distance 2B plus 2 is less than 4. What is the shortest distance to B? It is 1. Why? Because we have inferred, or we have obtained that information in our last pass of the shortest distance technique. So actually the distance to C from B is actually 3. Remember, as I mentioned at the starting, that the shortest distance is the sum of the shortest distance among the in-between locations. So it is actually 3. And 3 is less than 4, so I'm going to change it to 3, and I'm going to update the value on the third column to be B because we are at B and we have changed the distance to C. The value of the second row does not change because we are at B, and the value in the first row does not change. This was our second trick, that we are going to update the distance, and the value of the distance is the shortest path to our current location plus the distance from our current location to our neighbor, and if that is less than the existing value, we update it because we are interested in the shortest path. Right, now we mark A and B as visited. We only have C, so we go to C. We see that the neighbors of C are A and B, and we have already visited them, so there is nothing to do. We'll keep the values as is, and we notice that all the locations are visited. So we are done. So what we have understood is that the shortest distance to C from our original is 3. Right, now there is a second part of the question. What is the path, or how are we going to reach C? To do that, just have a look. The shortest distance to C is 3, and we have obtained it via B. Right, so we know this information, that to get to C we have to come from B. Now how did we reach B? We have reached B via A, and A is our starting location, hence our path is A, B, C with a distance of 3 km, and that is our shortest path. Let's do a recap of what we have learned. First, figure out who your neighbors are and remove the neighbors that you have already visited. Second, calculate the distances to each of your neighbors, and if any of the distances are less than the existing distance, update the information in the table. Next, pick the location which has the least distance and visit that location. Continue till you have visited all the locations.